Welcome to Brain Vision.
This question is asking us that how does the density of a gas depends on temperature, and how does it depend on pressure, and how does it depend on the molar mass of a gas? So we know that density is mass divided by volume. Okay. So how does the density of a gas depends on the temperature? From the simple kinetic theory of gas, we know that volume is directly proportional to temperature, right? And volume is inversely proportional to pressure. The first one is Charles' law and the second one is the Boyle's law. So let's start with the Charles' law. The Charles' law shows the dependence in that when you have a gas and you increase the temperature, that means that the volume of the gas will increase. So increasing temperature leading to an increase in volume of the gas will lead to a decrease in density, because if volume increases, density is going to decrease. So it's just the other way around. So when you decrease temperature, volume decreases and density increases. So that explains how temperature affects the density of a gas. Now let's go to pressure. Pressure is inversely proportional to volume. So that means that if you increase pressure, volume decreases. So a decrease in volume will lead to an increase in density and vice versa. Now, how does the density of a gas depends on the molar mass? So we know density is grams per liter, or density is mass over volume, and that can be obtained from molar density by multiplying the molar mass. So for instance, we can say density is equals to P N over RT. And the way I got this is by saying that, okay, you know the ideal gas equation is PV is equals to nRT, and volume here can be replaced by saying volume is nRT over P. So if you replace volume here with nRT over P, you're going to have P M over RT. And as a matter of fact, you can put n here where n is equals to 1. So we're going to have this expression where P is pressure as usual and T is temperature. So this is how the molar mass affects density. So density increases with increasing molar mass, and density decreases with increasing temperature. And if you might think, I said here that this is mass, right? And all I did was just to replace the mass with molar mass. So you can remember that number of mole is equals to mass divided by molar mass. That means that mass is equals to n number of mole multiplied by the molar mass. So I did some unwieldy trick here by crossing this out. So if you replace this n by this expression, you have n, and that is why I just make this to be equals to 1. So this is just 1, 1. And that is how the molar mass comes into play. So that means that an increase in molar mass will lead to an increase in density. Yeah.